So on behalf of ARMA and the Induced Seismicity Technical Committee, chaired by Ahmad Ghassami, myself, Sean Maxwell with Ovintiv, Jens Stern with USGS, and Mahdi Haddad with the Bureau of Economic Geology, we welcome you to our monthly webinars. So this month, we're going to do something a little bit different. So we're pleased to have Dave Eaton and Rebecca Salvage with the University of Calgary with us. And we're going to run a webinar focused on the November 22 Peace River earthquake sequence. And Becky and Dave have agreed to run this as an interactive session. It's some research they've been doing, leveraging some online polling to try to differentiate between induced and natural events. So I think it'll be of interest to the community, both from the technical content they'll be presenting on the earthquake sequence, which are interesting, as well as for us, for the ARMA committee. It's a different format, so we'll see how this goes, but we're looking forward to an interactive session where people can weigh in on this topic. And rest assured, Dave and Becky will go through the rules of engagement and give lots of context of how this will be run in a few moments here. Just before that, though, our normal introductory slides. I'll pass it over to Jens to talk to upcoming schedule.
Okay, good morning, everybody. Three things to say. First, this webinar is a good follow-up to the one that we had last month by Han Kao, and I believe that one is available on our YouTube page that Mahdi will mention shortly. That's point one. Mahdi can confirm that. Point two, we will not have a webinar as you know, next month in the time we normally would, in recognition of the 57th Rock Mechanics, Geomechanics Symposium for ARMA happening in the month of June, on those dates there. And then the final point to make is that we have one more speaker planned already, and that is for the first Friday of July, the 7th, and that's Eve Guglielmi from Lawrence Berkeley National Lab.
And just before we move on, just a reminder to everyone, as Jens said, June, as always, we won't hold the webinar to avoid conflict with the ARMA Symposium, but it's an interesting program. I'd encourage everyone to take a look at the program and consider attending. So you can see the link there on the bottom of the slide, and we'll put that in the chat as we go through the webinar.
Good morning, everyone. This is Mahdi Haddad from the Bureau of Economic Geology. Welcome to another great webinar of our Induced Seismicity webinar series. So first of all, I would like to encourage everyone to share these invitation emails sent by me to your interested colleagues of the topic of induced seismicity. We have almost 600 people in the list, consisting of 44.8% from academia, 4.1% from regulatory agencies, and 51% from the industry. So, but we would like to extend this community to more people and share this content with more interested people to this topic. So a little bit about logistics of this webinar. Everyone will be muted during the talk, but during the informal section of this webinar, you can unmute yourself and ask your question personally after 1 hour of this webinar. And please submit your questions during or after the talk in the chat function at the bottom of the Zoom meeting window. And please send these questions to everyone in order for us to summarize the questions or ask the questions once if they are repetitive. And this specific meeting will be recorded upon request by the presenters, and it will be uploaded on our YouTube channel for your later review. As Jens mentioned, we have several recordings of the previous webinars in that YouTube channel, including Hong Kao's presentation. Please refer to that. It has a lot of good content for you to review for the history of this webinar series. This is the 40th one webinar. We have a lot of the previous webinars right there for you. And please subscribe to this YouTube channel for the future notifications. Without further delay, let's invite Rebecca and Dave to take over the stage.
Thank you so much, everyone, and thank you for being here. Hopefully you can all see my screen.
Yes, we can.
Yes. That's great. So as Sean and other people have mentioned, this is going to be a little bit different. So bear with us while we try and undertake this webinar. What we're going to do is I'm going to talk a little bit about the Peace River earthquake sequence, which was began kind of in November of last year. And then we're going to take some online Zoom polls asking you to answer questions related to this sequence to try and get a better understanding of whether this was induced or natural. Now, I'll go through how this is going to work in a little bit more detail, but just to start with, this is kind of the outline. So I'm going to start with some natural versus induced seismicity in Western Canada, just in case people who are from other areas of the world are here. Then I'm going to talk in a little bit of detail about the Peace River earthquake sequence. And we're going to do some interactive Zoom polls based on that. Now, the data that the Zoom polls are going to be based on only goes up to March the 10th of 2023. And the reason for that is because Dave and I convened an expert panel of 10 scientists in March and asked them exactly the same questions. So what we're hoping is that everyone here will help us to increase the statistical analysis that we can do with this work. So that's why you will only get to start with data up until March 10th. I'll then go through a little bit about what the previous experts found. With so many of us online, it's going to be impossible for us to analyze it sort of on the fly. So we will have to wait for the actual results from this Zoom poll. And then I'm going to give you an update on what's actually happening now. So from March through to May, what has been happening with this Peace River seismic sequence. And then just end with a little bit of chat about the challenges for rapid discrimination of these types of seismic sequences. So to get our eye in, I'm just going to move my Zoom controls here. Hopefully. There we go. Okay. So for those not based in Western Canada or who haven't done much work in Western Canada, much of the seismicity in Western Canada falls either within what's known as the Western Canadian Sedimentary Basin, which is outlined in black, or falls on the west coast of Canada related to the subduction zone and also the strike slip fault, the Queen Charlotte fault, which sits off of BC and further north. So within the Western Canadian Sedimentary Basin, there have been about 7,300 events. This is greater than magnitude 2 since the year 2000. We can see the maximum was about a 5.7. Outside the Western Canadian Sedimentary Basin, so plotted in gray here, obviously many, many more seismic events, like 32,000 with a maximum magnitude of about 7.8. So the seismicity that's off the coast of Vancouver in that area is dominated by natural seismicity. This is related, like I said, to the plate tectonic that we have in Western Canada. But if we split the seismicity actually within the Western Canadian Sedimentary Basin, we can look at it sort of based on 60 degrees north. Those events which fall north of that line are primarily driven by natural plate boundary interactions. So we have the Mackenzie Mountains up here, for example, which produces a reasonable amount of seismicity in Canada. And this is also related to sort of far field effects relating to the subduction zone, which sort of bends around here into Alaska. If we look south of the 60-degree north, we see a mix of both induced and natural seismicity. So induced seismicity in these areas typically is driven by unconventional oil and gas development, quarry blasts, potash mining, water disposal, et cetera, et cetera. So, but we do have a very a mix because of the far field effects potentially of subduction and the remnants of the building of the Rocky Mountains here. So just to get our eye in about discriminating between natural seismicity and induced seismicity, in particular in Western Canada, we think that natural seismicity is related to tectonic stress reliefs. It's relatively stationary on non-geological timescales. And importantly, the majority of intraplate earthquakes, so events that occur not related to the plate boundaries, so for example, those like we see in Alberta, have depths somewhere between 8 and 15 kilometers. And the mitigation for these kinds of events is to analyze them, to map them, and to design for resilience. So this is the NRCan peak ground acceleration map from 2015. So you can see areas that potentially have higher hazard than others, and that's based on previous seismicity in that area that is thought to be natural. When we look at injection-induced seismicity, we kind of believe that it's non-stationary, so it's related directly to that industrial activity that's happening. And fundamentally, it appears to occur at a shallower depth than natural events, so less than 7 kilometers depth, in particular in sort of Alberta and British Columbia, which is the areas that I'm most familiar with. We see some interesting characteristics of the seismicity in an idealized case. So those of us who work with induced seismicity sequences probably know that these are very idealized cases. It would be lovely if all of the seismic sequences followed these kind of rules, but they obviously don't. We sometimes see this triggering front where we have time versus distance of the seismicity related to the point of injection. So you can almost track the pore fluid pressure distribution with time. And we often also see a temporal correlation with injection rate. So as you change the injection rate or the injection pressure, you then get a change in the seismicity characteristics as well. And for mitigation of this, it's obviously very different. So we try and do things like avoidance, and there's obviously regulatory measures which are important when it comes to induced seismicity. So a little bit of background about the Peace River region. This is the approximate location of the main shock that occurred on the 30th of November, 2022. There are about 15 broadband 3-component monitoring stations within 220 kilometers of this. And the area is kind of, it's interesting because there's been operational activities in this area since the 1970s, but it's kind of split between a number of different activities. So we have in the kind of very shallow subsurface, in situ bitumen recovery. So typically at the moment that is using cyclic steam stimulation, but there's also steam assisted gravity and cold heavy oil production as well. In more recent years, this area has become more prominent for water disposal as well. So both of these activities are kind of coincident, they're ongoing at the same time. So there is some potential for some associated seismicity here. So now it may seem a little strange that I'm giving some backgrounds to the regional seismicity and to other things, but all of the information that I'm trying to give you here will aid for the questions in the questionnaires that we're going to use on the Zoom poll. So bear with me. If we look at the regional seismicity in the Peace River region, so this is the area, you can see this is from the AER, so the Alberta Energy Regulator. The events are plotted on the right-hand side from 2006 to March 2023. This is the Peace River seismic sequence that we're going to sort of be looking at. You can see that sort of from 2014 to 2018 in this area, there was some regional seismicity in this area to the northwest of the main shock. But most of the seismicity regionally occurs obviously in the Cape of Duvernay, which is further south. We have the subsurface order number 2 here. So this is under stricter regulatory control, I guess. But there are a number of other areas where induced seismicity may be occurred. So you can see that this area had already been highlighted as potentially inducing seismicity from disposal a number of years before the main shock in 2022. And we can see that water disposal seismicity or seismicity related to water disposal in this area has become more prominent in recent years. So here is the Musreau Lake cluster. For those of you familiar with that, this is primarily related to water disposal, but obviously much further south. But the area also has had some natural seismicity. So the event that's plotted here is the Dawson Creek event that occurred on the 14th of April 2001. It's about a magnitude 5.3, and it's been classed as natural primarily due to its depth. So it occurred at about 9 kilometers deep, somewhere between 9 and 12, depending on sort of the information that you take. But we can see that, although there's obviously reasonable amount of induced seismicity in this area, there's also the potential for natural seismicity. If we just compare that with the focal mechanism of the main shock, we can see that they're fairly similar, reverse type faults, very similar magnitudes as well. So it's not unheard of that this area would have significant natural events either. So just to look at the state of stress, here you can see the approximate location of the main shock here. SH max in this area is northeast to southwest, pretty much. You can see from these. Most of the data taken from this area is from borehole breakouts, some from seismic events, but predominantly boreholes. And we can see that they mostly all align pretty nicely with this northeast southwest orientation. So the initial details on the 30th of November of this sort of seismic sequence, the magnitude was estimated at about a 5.1. There are estimates up to about 5.6, but somewhere in greater than 5, I guess, is where we want to land. The depth was about 5 kilometers. This is potentially problematic because it sits right on the border between discriminating between natural and induced. And I've already said the focal mechanism is a reverse type fault that is fairly systematic in this area. I'll show you some of the geological history to sort of support that. And the event was widely felt. So here is Edmonton, for those of you familiar with Alberta. This is the main shock. So widely felt in Edmonton, obviously quite low intensity, no reports of damage, but still a reasonably large event for Alberta. So here is the seismicity catalog, I guess. This starts from the start of November 2022, so the month preceding the main shock, and then goes, like I said, to the 10th of March of 2023. So we can see, obviously here is the main shock, and this is a daily event count on the top and magnitude on the bottom. And here is the main shock. You can see about a 5.1. There was potentially some preceding seismicity, but nothing too untoward, except for in the hours just before, when there were two events greater than a magnitude 4. If we look at the decay of these aftershocks, this sequence here, we can see that potentially it follows an Omori type decay aftershock law, but I wouldn't hang my hat on that fit, that's for sure. So it appears that although some of the sequences following this type of decay, it may not be characteristic of it. So if we look at the locations and a bit more about the characteristics of this seismicity, what you will notice is that the events cluster very closely to these 3 disposal wells. So A, B, and C are or were currently active disposal wells in the area. The seismicity clusters very closely to those. We have magnitudes between 0.31 and 5.1. And the magnitude of completeness is reasonably high here. It's at 1.71. That's because we're only using public station data, so no close array. The closest station is actually about 20 kilometers away, so not that particularly close. And what we do see though is a reasonably low B value, which is probably related to the fact that we have a number of events greater than a magnitude 4 in this sequence. The depth resolution due to the station distribution and the distance is poor. But they typically lie between 2.5 and 4.5 kilometers depth. So in that shallower range of the subsurface. And if we look at the focal mechanisms, here are the 2 main shock, 2 foreshocks that were greater than magnitude 4. Then there's the main shock, and then 3 aftershocks, which are sort of all greater than 3.8, but occurred within the following few hours. We can see they all typically follow this reverse type focal mechanism. The depth of these events ranges, like I said, from like 2.7 down to 5 kilometers here. So reasonably shallow, and you can see them plotted in map view here as well. So something really interesting, and I guess lucky at the time, was that a satellite passed over the Peace River region on the day of the earthquake. So we were able to capture some INSAR signals. This is courtesy of Sergei Samsonov, who's at NRCan in Ottawa. So what you're seeing here is the ascending track of the satellite. This is on the 30th of November, so actually the day of the earthquake, and here's about a week later. The interesting thing about this is that you can see the sort of red blob represents uplift, and that is associated with this, this main shock and this seismic sequence. Now, Interestingly, the deformation signal suggests it's about 4 centimeters at the surface, which is really quite significant. There are no reports of damage, even to infrastructure or anything, but 4 centimeters of uplift is certainly significant. And this has been modeled from a fault which is somewhere at about 3.4 kilometers depth. So the uplift is caused by movement on a fault in the shallow subsurface. So just to give a little bit of geological setting, contextual background, the main shock, as you can see here, sits basically on the edge of the Leduc fringing reef, which some people have suggested may play an important part in having faults which may be critically stressed or that may be more prone, I guess, to inducing seismicity. Something else we can see from the AGS, this is from the Alberta Geological Survey's 3D geological model in this area. Here is the approximate location of the main shock. The Leduc reef here seems to have a very large change in elevation, very, very close to where the seismic sequence is occurring. And this has been interpreted to be a fault in this area. It's also important to note that the pink down the bottom here is the basement. The Leduc, which is the formation into which they are injecting, sits very, very close to the basement here. So in some cases, it's the next formation in terms of its elevation. So there is some other evidence of significant faulting identified on 2D seismic in this area. This is from a paper in 2014 by Weeds. There are significant faults, and this is the approximate location of the main shock here. So you can see we probably sit somewhere between these identified large faults from seismic, and this is probably related to the Fort St. John Graben complex and the Peace River Arch complex, which sits further west of here, but probably extends towards where our main shock is happening. So some of the potential mechanisms, I said that there was active water disposal in the area. Here's the approximate location of the main shock again. This map shows the disposal wells in the area. If it's highlighted in blue, then that means that it's previously active. Those which are blue with a pink center are active in November of 2022. So what you can see is that the closest wells to this main shock were indeed active at this time. And if we look at the injection history, so this goes back to the year 2000 for the wells sort of in the near vicinity. The three which are closest are in color here. We can see that they sort of started injecting sometime around 2013, but so a decade ago. But there has been active disposal in many of these disposal wells since 2000. So it's an interesting question. If this sequence is induced, why does it take such a long time for it to generate a seismic sequence? So the nearest active disposal well, which is this one here, is well A. It's less than 1 kilometer away. That is the very dark blue color, and that is injecting into the Leduc formation. So just to quickly look at what they may look like schematically. So I said before that there's some bitumen recovery that's in the very shallow surface here. The three closest wells, so A, B, and C here, are injecting into the Paddy, the Debolt, and the Leduc. Here is the basement. The well A, which is the closest well, is injecting into the Leduc here. we can see the main cloud of seismicity represented by this gray oval, and the approximate location of the main shock here. So we can see that seismicity extends down into the basement and also up into the Leduc and into the overlying layers here. So here we go. We are going to try and use all of this information and do an interactive Zoom poll right now. So the way this is going to work, we're going to use two assessments. They are two questionnaire schemes that have been published recently in the literature. The first one is by James Verdon from 2017. And the second one is by Fulger, so Julian Fulger, in 2023. They try to distinguish between natural and induced events. There are several questions. The answers are weighted dependent on the observations that I have shown you, but you won't see that in the Zoom poll because there's no way to enter that information. But what is going to happen is I'm going to launch two Zoom polls. So the first one will be the Fulger 2023 scheme, and there will be about 5 minutes that it will be, should be on your screen. Please remember to scroll. There are 9 questions within this poll, or 10 questions. The first question will rate your previous knowledge of this earthquake sequence. So we want to know whether you have no knowledge of it whatsoever or whether you're studying it yourself, just to give us a little bit of background information about how this will work. And then that's followed by 9 questions. So please remember to scroll. They are single choice answers, so you can only click 1 per question. We'll then stop that and we'll run the Verdon scheme, which will also have 5 minutes. Again, the first question will be to rate your previous knowledge of this earthquake sequence. It's the same question. And then this is followed by 14 questions. And don't be alarmed, there are actually only 7 questions, but the first one is a question that is a single choice answer. So it'll ask you to make a choice. And then the second part of that question will ask you to estimate how confident you are in your answer as a 0 to 100% value. By taking part in these polls, you're agreeing that the data that is collected from this can be used anonymously by us in future publications and in presentations. And we thank you all very much for doing that. So I'm going to try and launch the first poll. Oh, that's not what I wanted. Okay, let's go again. I'm hoping everyone can see the poll. Remember that you do need to scroll in order to answer the questions. And as they would say in England, when we sat our exams at school, ladies and gentlemen, please put your pens down. That is the exam finished. I'm going to end the poll. Dave, can you let me know when you have downloaded the results so we don't lose them?
I've downloaded the results now.
Okay, so now we're going to do the Verdon scheme. So this is a separate scheme. Again, kind of similar questions. This one will ask you a single choice question, and then the second part of that question will ask you to rate how confident you are in answering that question. So again, remember to scroll through the questions. And I'm going to leave it up again for about 5 minutes. So thank you very much. really do appreciate it. I'm going to share the results of the Folger questionnaire, just so that you guys can have a little bit of first look at the results. So did the earthquake activity sequence begin before, during, or after? Most people went for began while industrial activity was substantial. Spatial correlation between the earthquake sequence and industrial activity. Again, earthquakes are likely within the area of environmental modulation, so likely within that. Spatial co-location between the earthquake sequence and the volume of environmental modulation. Perhaps less, but the earthquakes are likely within the likely volume of the environmental modulation by industrial activity. Is there temporal correlation between the earthquake sequence and specific industrial events? That's kind of split between strong temporal correlation and weak temporal correlation. So, is there evidence of pre-industrial earthquakes at or near the site of the earthquake sequence? That comes down to occurred in the wider region around the site of the earthquake sequence. Evidence of pre-industrial earthquakes in the same volume as the earthquake sequence. Very split between insufficient information and pre-industrial earthquakes occurred in the wider region around the site at similar or shallower depth. Are the focal mechanisms consistent with a natural or induced earthquake cause? Consistent with the regional stress and are consistent with the proposed induction mechanism, or the focal mechanisms are not consistent with the regional stress and not consistent. Are there any other seismic data to support a natural or induced cause? So we've kind of got a split between being supportive of induced and being equivocal, and non-seismic data that support a natural or induced cause. Oh, that was really split right down the middle with all of them. So thank you very much. Dave, I hope you have been able to download all of the results.
They're all downloaded now.
Great. I don't know how to get rid of the poll. Oh. Zoom. You would have thought after so many years we'd be all right at it, but okay. I'm assuming none of you could see the Zoom poll that's right in the middle of my screen, but I can't seem to.
I think you can just exit, Becky, at the.
Don't have an exit button. What's the problem?
No, just the red, the usual closed window.
Okay, I'm gonna have to wait to get rid of my Zoom controls. Go away. There we go. Okay, fab. Back up and running. So I'm just going to give you a little look at the panel that we convened on the 10th of March, the results that they came in with. So we had 10 experts, like I said. They were asked to do exactly the same as what you did, but not via Zoom. They're based in the US, the UK, and Canada, and we had expertise between both natural intraplate seismicity and induced seismicity. They were presented with the background in the same way that you were and asked to complete the Verdon and the Folger schemes. Now, the interesting thing about this is that this panel, like I said, was on March 10th. So it predated the March 16th resurgence, which I'm going to show you in a minute. The publication by Ryan, which came out pretty much the week afterwards, I think, which said that they believed that this sequence was induced. And it also came before the March the 23rd order under the Environmental Protection and Enhancement Act for Obsidian Energy, where the regulator asked Obsidian Energy to enhance their monitoring, basically, in that area, because they believed that some of their processes were responsible for the seismic sequence. So here are the results of the Folger scheme for our 10 experts. So red means that the expert believed it to be mostly be likely to be induced. Green is natural, white is no data, and yellow is equivocal, so it could be induced or it could be natural. You can see most of our experts believe that the sequence was induced, but there's non-trivial parts of each pi that come down to no data or to equivocal as well. So it wasn't a slam dunk in the case of the experts. And I think the results, just briefly having looked at them from you guys as well, I think it's going to be not going to be a slam dunk either. So as to either way. So let's just really quickly look at what's been going on at the Peace River earthquake sequence in the last couple of months. So I said, here is the event, the main shock on November 30th. This was initially declared as natural by the regulator. Here's when our expert panel members was conducted. Here's when the expert panel meeting happened. Here is the resurgence in March. So you can see in March 2023, there were several greater than magnitude 4.5 events that occurred. And here is the environmental protection order that was against obsidian energy. We can see that this aftershock sequence is still ongoing. The magnitudes are somewhere between the magnitude, I don't know, 1.5 to 3.5 maybe. There's not as significant number of events as there were in sort of the month following the November main shock, but we're still getting seismicity in this area, which is related to this same sequence. The magnitude of completeness is still exactly the same. The B value has shifted ever so slightly, but it's still very, very low. And again, the Amori decay, I wouldn't like to hang my hat on that because I think potentially there's some evidence of an Amori type decay in perhaps the month following the main shock in November. But as this sequence is so extended now by several months, I think this sort of type of Amori decay analysis is not really capturing the characteristics of the sequence anymore. Here is the locations of the events. Here's the sort of big purple is the main shock in November. Here are the green ones are the magnitude 4s that occurred in March. So you can see they're co-located in the same sequence. We've had some recent activities shown in the yellow. So this sequence is still very much active and is still ongoing. Again, we've still got poor depth resolution because we're using public stations, but they still all typically sit somewhere between 2.5 and 4.5 kilometers. Just to have a little look at those two aftershocks that occurred in March here, so these two green dots, we can see the focal mechanisms of those two aftershocks are very consistent with the focal mechanisms of the entire sequence. We think they're reverse faults, probably related to the reactivation of normal faults, steeply dipping normal faults in this area that occurred as a result of the collapse of the Peace River Arch here. And it's not uncommon in this area to have the reactivation of those normal faults as a reverse type mechanism. So just to briefly look at some of the challenges that I'm sure all of you have had. If you have any specific comments related to the questions or the polls or any of that, please do get in touch with us. We'd love to hear from you how we're able to potentially make this easier or better in the future. So there's obviously challenges with data availability. We have no pressure data. We've only got monthly injection data. Operations in this area began before historical seismicity databases. These are all things that come into play when you're trying to assess the sequence. There's obviously issues with data quality. Anyone who works in this field knows that data quality is always an issue and can lead to some large errors, in particular in depth of these seismic events. There's probably some implicit bias in delivering the schemes, similar to how today I have tried to give you the information impartially. I was the person giving the experts on March the 10th the same information, but I have my thoughts on this sequence, I guess. So it's possible there's some implicit bias there from delivering these schemes. And there's potentially some issues with some of the schemes themselves. There's lack of precision in some of the key terms. So I think in both of the question, there's one question about regional seismicity. Now, it was up to you as the expert to decide what constituted regional seismicity. Did you go for 20 kilometers, 50 kilometers, 100 kilometers? You know, it's difficult to not all experts will have thought the same in terms of what regional means. And there's questions about what if one answer holds more, if more than one answer holds merit, then you were only able to select one answer per question. So, you know, what if you were umming and ahhing between those two? So just to summarize very briefly, we've got several new schemes that have been published recently, and they're aimed at discriminating between natural and induced seismicity. We convened an expert panel to apply these schemes to the March Peace River earthquake sequence. So on the 10th of March, we had 10 experts. And on the 5th of May, today, we've had the ARMA webinar where I think we've got about 30 responses. So thank you very much to all 30 of you who responded. The original expert panel largely agrees with Schultz and attributes the sequence to brine disposal or injection-induced seismicity. And we've found a number of challenges for rapid assessment, including data availability and lack of precision. Now, these schemes, when they were first thought up, or our understanding is that they have typically been used in hindsight to apply to earthquake sequences where there's been reasonable amounts of research into that and into those sequences. Whereas this time we were trying to apply these schemes to something that was still ongoing, where people had very many different opinions, so it was definitely an interesting exercise. So just to acknowledge, obviously our expert panel on the 10th of March, everyone who funding and processing made this, and special thanks to all of you for taking part in this, and for the ARMA webinar team for taking a chance on this interactive experience. Well, thank you very much. And with that, we'll open it up to any questions if we've got time. I don't know what time is.
Yeah, we've probably got a few minutes here for questions, but and if you're able to stick around at past the hour, we can have more of a informal discussion maybe. But thank you, Becky. Really interesting sequence, and it's I think an interesting experience to see the data and go through one of those interactive polls. I guess I will maybe, we can have more of an informal discussion here in a few moments, as I said, but I'll maybe just ask one quick question, just to maybe put this in context. So the original kind of Davis and Froelich paper, I think they had sort of 7 questions for the same notion to distinguish induced from natural. Can you just comment, are these pretty much just variations on a theme between the original Davis-Froelich work and Julian's and James?
Yeah, they are. And the Davis and Froelich work, so that was in '93, I believe, was, I think, a true-false kind of scenario. So they didn't give you the options, like the Folger scheme and the Verdon scheme give you this option, like there's not enough data. I don't know. But they are all kind of variations on a theme related to, the seismic sequence itself, the injection history, regional seismicity, faults in the area, all of these kind of things that we now think are particularly important when assessing induced seismicity sequences. What I would say for all of the schemes is they are focused, I guess. The questions are focused more towards induced seismicity than natural seismicity. So probably because they've all been used to try and say whether they think a sequence is induced or not. There's not a lot of questions that particularly would apply only to a natural sequence. And what those questions would be, I don't know, but it's certainly more focused towards induced than others.
Great. Well, we've reached the end of the hour, and there's some questions in chat, so it'd be good to go through those. But just to kind of wrap up the formal part of the webinar, I'd like to thank everyone for their attendance. And Becky, if we could, it'd be, I think, maybe of interest if you could summarize these results, and we could maybe distribute with the community. I think there'd be interest in seeing those kind of results. And I'll remind everyone, Yves Guglielmi will be giving the webinar July 7th, and there won't be a webinar in the month of June, just to avoid conflict to the ARMA symposium. And anyone that's interested, in the chat window, I put in the link to the ARMA website that has the technical program for the symposium. I'd encourage everyone to take a look and consider attending. It's going to be an interesting ARMA symposium as always. But again, thanks Becky and Dave for helping us out and providing the webinar. And thanks to all the participants for participating in the poll.
Thank you. Thank you.
And we're happy to stick around for a short time to have a more informal discussion. There are some remaining questions in the chat.
Yeah, do you want to go through those? Maybe starting with that first one on Dave. I think you did a good job kind of responding to the questions as they're coming up, but
there was one that I did not respond to by Oyewole Fortune, because I felt that responding to that question could bias people when they were doing the polls. So the question was, if you're injecting into a sedimentary unit and the earthquake focus is in the basement, shouldn't the two be isolated since they have different competencies? Or I guess, the mechanical properties of the sedimentary units in the basement are very different. And the quick response is that we know from places like the central US, Oklahoma, Kansas, and other places that injection into a sedimentary unit that immediately overlies a basement can create or induce earthquakes on the basement parts of deeper faults. So that's just an empirical observation. And I think there's lots of research still to be done and better understanding the geomechanics of that. But I don't think we could say because an earthquake is nucleated in the basement and injection was occurring in the sediments that they're not connected. So, and I noticed there was one from Michelle Gaucher, and I'm not sure if she's still on right now or not, but about, hi, Michelle.
I'm still here, Dave.
Yeah, thanks for the question. And you were asking if we see value in high resolution injection data, and absolutely, there's tremendous value that we could get in understanding pressures and injection rates with much higher resolution. Right now, all we're able to access for this sequence is monthly average, well, the monthly injection volume. So and it's actually reported as an average rate, as if they were injecting at a steady rate through the whole month, but we know that's not the case. So I think the value of the monthly volume is pretty limited for understanding, for us to build the kind of hydromechanical models that we'd like to do. Becky and I are actually collaborating with a reservoir engineer to try to build a model, and she just kind of shakes her head that she wants to history match curves, and she can't do it with very limited information we've got. So really, all we know is they're still injecting, into that well, and we can say something about the volumes, but I think to sort of dig deeper into the underlying physical processes is extremely difficult without having that information. And Ryan had a question too. I'm not sure if Ryan's still on.
Yeah, I'm here.
Yeah, so you wanted to know about the cadence of new polls. So as new information becomes available, how frequently should you do that? And that's a great question. I think that there is considerable value in repeating polls, as new information becomes available. But you don't want to do it too frequently, because then I think you're just working in the uncertainty of each poll. Like any change in results from a previous version would be hard to interpret, because this could just be uncertainty manifesting in the results of the poll. I guess if I had to guess, I'd say wait 6 months and then redo a poll after 6 months and see what's changed in terms of what people understand.
Maybe, I guess, do you think time would be the right metric, or is it after some sort of new significant finding, I guess, comes out about it? Or I'm just curious to hear your thoughts, because I know this doesn't necessarily have an answer to this question yet, but.
Yeah, I think probably some combination of those, because, I think also you have to, if there's a new significant finding, I think one has to allow a little bit of time for people to understand and process that information. I would say, you don't sort of re-poll immediately too quickly following new results. You have to give it some time. So maybe a month after new results, or every 6 months, just because there's an accumulation of new information that is more gradual, not necessarily, a step-like function in new information. So I think having a bit of a longer time to establish a cadence for these things would be good.
Presumably, too, it'd depend on if some operational change was made, right? If, for instance, injection ceased at a given point in time, then build enough observation time to look at the negative response that could equally be informative of causation.
Hey, Sean and Dave, are these operations actually being pumped above fracturing pressures? Do we really know the stress? Did anyone measure it?
So I'll tell you what, I've had some conversations with the regulator about this, and the pumping is taking place below the fracture pressure, so in these disposal wells. And the operators of this and all wells in Alberta, even those that have been associated with induced earthquakes, are occurring at pressures below the permitted maximum pressure. So,
right, by the way the fracture pressure is calculated by the regulator is including frictions, because they do that step-up test. They never do, they rarely do diagnostic fracturing and try to stay below the closure, not below the fracturing, because that fracture is including, like I said, all the frictions. So you may actually generate fractures.
Okay, so I think I just have to plead ignorance on the details to try to answer that question. But I've just revert back to from a regulatory perspective, the operators believe that they are operating within their permitted pressure, maximum pressure guidelines. So they're not doing anything that they're not permitted to do.
Can I pipe up here? I'm a newbie to this forum. My name is Jim Sterling. I'm a reservoir engineer by background. I'm working in the carbon capture and storage space. I was in touch with Ryan Schultz when the paper came out, because it has implications for carbon capture and storage. One of the observations I'd have is, I come from an offshore background where we use thermal effects to actually induce fracturing in some cases for offshore water injection. And I often find it interesting why nobody talks about temperature effects related to injection. These water temperatures that I would expect we're injecting at are going to be quite low relative to formation temperatures. And I don't know if any of that is part of the regulatory guidance as temperature effects.
Yeah, no, I think that's an excellent point. So thermoelastic effects. So stress changes associated with the thermal shock of injecting a lower temperature fluid into a hotter host material. And I think geothermal, that's a significant consideration there as well. So this is a very nebulous answer, but I think that these are extremely complicated systems, and we have to understand that there are many different factors and there's an interplay between different effects that we have to consider. And as a researcher, I will, sort of selfishly say that I think we need more data. We need to monitor these things more closely and provide access to that data so that that can be used to better understand the systems.
Yeah. So the two key things I would take away in terms of data would be the need to monitor more closely the injection through rate and pressure and temperature. And then the need, especially in the carbon storage world, to establish some baseline conditions so that you understand whether your operation is impacting the natural environment.
Mm-hmm.
And I think those are two changes that could be easily made in the regulatory guidance. But I think most serious for me as a bystander is if the ground heaved to the order of 3 centimeters at surface and there's a SAG-D operation going on at the order of 400 meters depth, then what happened to the cap rock? And is there any evidence that they lost integrity of the steam chamber being used to recover the bitumen?
Yeah, that's great. By the way, it's not SAG-D, it's cyclic steam stimulation, and the operations are at about a kilometer depth rather than 400 meters in this area. I think that there's ample scope for follow-up studies for this particular sequence to better understand infrastructure, response, and fragility, because there was significant ground displacement that occurred as a result of the main shock. But we do know that the disposal well continued to operate. So therefore, the disposal well was not impacted to the extent that it could not still be used. We also know this area is crisscrossed with pipelines. So I think that work needs to be done to better understand how does this type of infrastructure really respond to ground motions that occur for an earthquake of this magnitude? But if I could, I was hoping we could get to a question that Gail Atkinson raised, which I think is a bit philosophical, but really important. Gail, are you still on the line?
Yeah, I'm here.
Yeah.
Hi, Dave.
Hi, Gail. So you were asking about what's the ultimate use of this type of poll?
Yes, and you're right, it's philosophical.
But I think what we were naively hoping to sort of move towards is, can we distill out of these published schemes a way to do a rapid determination that would at least attach some probability to it? So I think our goal is to identify, what are the gaps in the existing schemes? What are the gaps in the information that's available to researchers that would allow one to do it? And is it even possible to do that? Because I think what would be really useful is if there were a way to, to relatively quickly after an event has occurred, to attach a label to it,
Type in a sort of a thing that I was thinking is that would be very interesting to do is, first of all, there's the issue that you can't really give it necessarily a binary label right away, yes or no, classic like that. So I think that, your phrase of attaching a probability is a good one. And what would be really interesting to do is to see how that probability assessment evolved with time, which goes back to Ryan's point. So if you could kind of do this assessment of so a day after the earthquake, the probability that was attached to it being induced was, say, 30%. And then information that came out a few months later, that went up to 60%. And then by a year after the event, it had changed to 90% or whatever. Maybe it went the other way. Maybe sometimes initially it's thought to be induced and then later information shows that it isn't. So it would be really interesting to see how the likelihood that something was induced or not sort of evolved with time.
Yeah, I totally agree. I think that'd be fantastic. And that's our goal, is to have developed some kind of quantitative, objective process to do that. And as a starting point, we're using these established schemes.
Dave, is there also a...
Sorry, go ahead, Jens.
In addition to what Gail was just mentioning about the, evaluating over time the probability of it being induced versus natural, in places like West Texas and Oklahoma, there's the question about if it's induced, which is, in many cases likely in those places, what was it induced by, hydraulic fracturing, let's say, versus wastewater disposal or whatever, and maybe even, specific wells and so on. And I'm wondering whether you have an intention to include any of those sorts of questions in your, what you're developing.
Yeah, I think that would be also very interesting to do. And I think that question gets even murkier as, more types of operations come online, like carbon capture and storage, hydrogen, subsurface hydrogen storage, et cetera, enhanced geothermal systems. And then also, I think we have to give some careful thought to what would that attribution actually accomplish. So I think as scientists, we really should be trying to achieve these kind of things, like set that as our goal. But I think we also have to understand limitations on what we're able to do. I did notice that there was a hand raised. I think it was Bill.
Yeah, I think Bill Curry was going to ask. I was going to ask the same question that Jens asked. So I think multiple people.
I was, but to be honest, what you just said, David, kind of made me think is that understanding what the potential causative factor is kind of our first step in trying to address it, right? So it's something really important for us to at least have an idea of. For instance, the Permian is an example: shallow disposal versus deep disposal versus hydraulic fracturing, and we, to be honest, don't really think of any of them being tectonic in origin. There. And so I have to admit, with this Alberta event, kind of my assumption was you assume it's induced unless you can prove otherwise, I guess, which here with the depth constraint seems like it's not an easy thing to do.
Yeah.
Anyway, it's been really fun.
Thank you. Yeah. So, and the other thing is that I think we're starting to significantly overlap into the legal regulatory space too. And so I think that is something that, the scientific community, it's important that we do this, but we also have to, to a certain extent, stay in our lanes and collaborate with the people who do have expertise in those areas.
Dave, I have a question about the glaciations. What do you think is the impact of multiple glaciations on these rocks sitting on top of these disposal zones or all the way to the basement, especially in this area?
Yeah, so in the past, I've supervised students who've looked at induced or seismicity that's linked to glacial isostatic adjustment. And so, of course, this whole area was glaciated until about 15,000 years ago during the last Holocene glacial period. And the crust is still responding to the removal of the load from the glaciers. That's a very long-term process. And I suspect that present-day seismicity rates are higher than the long-term geological seismicity rate. So this is just natural background seismicity today, because we are relatively, in geological terms, a short time interval since the last peak glaciation. That's really about all I can say. That probably we are in an epoch with elevated natural seismicity rates in certain parts of the world that are experiencing glacial isostatic adjustment. But but they're still very low rates compared to what we're seeing in response to industrial activities.
Right.
So
Thanks.
I can add one thing on that related to, I looked into this for the 2020 paper that I wrote with Mark Zobak on state of stress in North America. We were thinking more of areas further east that were covered by the thickest ice under Hudson Bay, for example. But probably a similar situation here where, because it's a more compressive, reverse and strike slip faulting environment, removing that ice meant that there was a release of the confining vertical stress, which would make reverse faults more likely to fail. And those are the well-oriented faults in this area. So there's a good chance that at least in shallower levels, it may have made, exactly as Dave said, it may have made reverse faulting more common and more likely.
Jens, you had an interesting question in the chat too about the mechanism. Do you want to? Oh
yeah, this is more of a comment, but I noticed that both of the surveys asked whether the focal mechanism geometry supports an induced origin or a natural origin, and I think that the second survey by Folger and others was a little bit more nuanced on that question. But the editorial comment here was basically that the vast majority of earthquakes we see in some places that are thought to be induced appear to be occurring on faults that are already well oriented and require very little pore pressure to make them fail. So by no means is that diagnostic. Well, I should say, if you see a focal mechanism that suggests a very poorly oriented fault within the stress field failed, requiring a large amount of pore pressure change, and that probably is a very helpful piece of information. But the alternative, the opposite, is not necessarily that helpful for distinguishing whether it was induced or not.
Yeah, I do think in conversations I've had with Jillian Folger, that questionnaire is meant to be very general. So it includes things like, underground explosions and mining related induced activity that might have some characteristic types of mechanisms. But here, for the kinds of seismicity that we're looking at, I don't think that the focal mechanism, I don't think there's any clear evidence that would suggest that there's a different focal mechanism for induced events than for natural events. I see a question from Andrew. Karen?
Yeah, I think at the bottom it says that you addressed it as well, but you can readdress it if you like, Dave.
No, I'm still digesting the question right now. So
you did a good job answering it.
Okay.
Apparently. Are you there, Andrew? Do you want to unmute yourself and...
Yeah, it was just thanks for this, by the way. Just that there's a lot going on in a very, depending on your scale, a large or a small area. And so I think it's quite a complex thing, and I do get kind of, I don't want to say concerned, but it's related to these sort of survey times, right? Like, hey, is this something that's induced or is it a natural event? And there's a lot going on here. So how can we actually digest all of that data, like all the injection pressures, volumes, if you only have monthly time series data for that sort of injection rates and all that good stuff. How do we digest this quickly in a very complex environment to come up with something that is leading us to a certain conclusion?
Great question. Yeah. I sort of in my mind, and this is completely unrealistic, but just to sort of pose the scenario, if we had access to the kind of computational approaches that the climate modelers have, so that we could continuously be feeding information into it about disposal wells and calculating stresses and take the best available knowledge about structures in the area, then we could apply we could make more informed statements. So right now we're trying to just base much of what we're doing on empirical information rather than those kind of numerical, really quantitative numerical approaches that are needed to understand the interplay between different, and that interplay is only going to get more important, I think.
Yeah, agreed. Thank you.
I don't know if Han is still on the line right now. Han Cow. Yeah, I see you're still there.
Yeah.
And you had posed a question or statement there about that this is going to get more important. You know, that even though it's overlapping onto regulatory territory, it can't be avoided. Maybe
yeah, I think the reason I'm saying so is that, as you know, the NRCan and Geological Survey of Canada established the Canada seismic risk model every 5 years, and that will be fed into the national building codes discussion and eventually become part of the law. Just recently, when we are in the process of putting together the next generation of the seismic risk model, that question come up. In other words, when we look at this Peace River sequence, and a very critical question is whether or not this is induced or not. If it's induced, as you know, in our earthquake seismic risk model, we actually take it out. This is meant for natural for risk coming from natural events, and therefore we take it out. If it's considered to be a tectonic event, then we will actually put it in. As you know, the seismic risk model, earthquake risk model, where we have deterministic component and probabilistic component, and if indeed this earthquake is considered to be a natural event, it will be part of the deterministic component, which actually will bump up the seismic risk assessment in that area. So I guess in terms of the following process in terms of getting together the next generation of national seismic model, this is important. Even though it probably step into the regulatory territory, but we have to do it. We have to get the answer out and have that information fit into the next generation seismic model, which will eventually affect the national building code for that particular area. So we probably should do it anyway. Doesn't matter how hard it is.
I think that's an excellent point. I'll just mention that I'm right now working on a new undergraduate program in energy science, and we keep getting told by our university administration that they want to push us to be more transdisciplinary. And so, scientists need to work with policymakers who need to work with social scientists, and so, so I think that the days of trying to work in isolation are sort of closing down, and we really do have to take on these issues and embrace opportunities to work in regulatory, policy, economic, and legal spaces as well, and find the right collaborators to do that.
So, Dave, do you have any update information from Alberta energy regulators' opinion about these events now? Do they still think that this is natural?
I guess my understanding is that it's shifted to equivocal.
Okay, I see.
And
I thought they had changed their mind. I may be wrong.
Well, they issued an environmental protection order, and they're gathering data. So there's installed an aftershock monitoring, a set of nodal instruments, which are being used to carry on a more detailed investigation. And the environmental protection order, as Becky mentioned, requires the operator of the deep disposal well to monitor. But I don't think the order means that they have to curtail the disposal operations at the well. I may be wrong there, but that's my understanding.
I see.
I think they've come out and said, unlike when they, after the first main shock in November, they came out and said it's natural. I don't believe they've reversed that opinion yet. They've just, like you said, in they've brought in this environmental protection order and they're doing more research, but I don't believe they've made a statement either way.
Okay, that's good to know. Yeah, I don't think I've heard their official announcement that it's induced, but as I just explained, we need to make a decision to include it or not. It's a tough decision from our side.
It certainly makes for an interesting sequence for discussions like this. So last month, Han gave an overview of seismicity in Western Canada and touched on this event. There's been obviously publications, and Becky, Dave, really appreciate you guys doing the webinar, and I think it was positive feedback in terms of the poll. So thanks for doing that.
Thanks for the opportunity.
Yeah, thank you for having us and taking the chance.
Well, again,
thank you so much.
I'd encourage you to, as you summarize it, Becky, Maddie can maybe distribute it to the community. I think they'd be interested to see what it looks like.
Yeah, absolutely. Yeah.
Awesome.
Sure.
Okay. Thanks, everyone.
Thank you.
Have a good day, everyone.
Have a good weekend, guys.